Hello, we're back. In episode 3, I said we'd be talking about the invader port to the Arduino Nano clone, using a breadboard, some resistors, a tiny screen, and a few buttons. It's programmed in C++ using the Arduino IDE seen here, and a library from Adafruit that's tied to the screen, an SSD 1306. Here's what the code looks like in C++ in the Arduino IDE. This is the Arduino Nano clone. An Arduino is a microcontroller. Unlike an SBC or single board computer like the Raspberry Pi, microcontrollers don't have an operating system and are not as powerful. But there are so many cool things you can do with them, and they fit in tiny spaces. Then there are chips like the ATtiny85, but we'll get back to that later. These are clones as they are not manufactured by Arduino, but are completely compatible with the Arduino's own boards. Okay, so now let's take a look at Invader running on the actual Arduino hardware. So here we have the Arduino Nano plugged into a breadboard, the small 128 by 64 black and white screen, it's the SSD 1306, a battery over here, 3 buttons, some resistors, and jumper wires. With this and the Adafruit library, we can create a playable version of our Invader demo. We also have a speaker here I still need to hook up. The Nano clones were about $13 for 3 of them on Amazon when I bought them, but now they're around $27 for the same set of 3. Still a bargain considering all the cool things you can do with them. So let's go ahead and run this. I'm going to hook up the battery. And there you can see it immediately popped into action. And we can move back and forth with the keys and fire. Again, there's no sound. I have yet to hook up the speaker. But here we go. We can shoot the invader and get some points, and we can also be hit by the invader and lose a life. Now we'll go ahead and maybe score another point or two, and then we'll take a look at the game over screen. And there you have it. So there it is, my Invader demo working on a game machine that I built with off-the-shelf hardware. This could be assembled onto a PC board and stuffed into a 3D printed case. Maybe later. One more thing, I've decided to show you the ATtiny chip for scale next to the Arduino Nano, which is already pretty small. That's the ATtiny, and I'm also going to be working on a version of Invader running on that little chip in the future. So I talked about the first 4 8-bit computers that I owned in my first episode. I first owned a Timex Sinclair 1000, then a Commodore VIC-20, moving on to the Atari 600XL, then the Commodore 64. After that, I graduated to a 16-bit computer, a Commodore Amiga 500. This machine had 512K of RAM as compared to my last 8-bit computer, the Commodore 64, or 64K of memory. It also ran at just over 7 megahertz as compared to just over 1 megahertz of the previously mentioned 8-bit machines. It also had full-color stereo sound and an internal floppy drive. I have emulators for all 5 of these machines right here on my desktop. Here's the Timex Sinclair 1000. The first thing you'll notice is with the old 8-bit machines is that as soon as you turned them on, they were ready for action, which is the appeal that people seem to be going back to now with the resurgence of retro computer programming. Next, here's the VIC-20. Again, notice the prompt ready for you to start programming something in BASIC. In fact, it even says ready. Now the Atari 600XL. This also emulates the Atari 400 and 800 computers, but I have it configured for a 16K 600XL. Again, ready to go. Now the Commodore 64. Notice the available RAM for BASIC. See how much is eaten up by BASIC itself before you even get started? You're left with almost 39K, and finally, the Amiga 500. Now you'll see that we no longer get the familiar friendly cursor telling us it's ready to go. Instead, we have to wait for it to boot up off a floppy. The price you pay for more power. Once booted up, I'll show you the boing demo in case you haven't seen it. I'm letting this go so that you can see how long it actually really took for an Amiga to boot up off a floppy. It's pretty accurate. And there it is. So we're going to go ahead and open up the workbench, Amiga's operating system. And again, just in case you haven't seen it, here's the famous boing demo. That's what multitasking looked like back in the late 80s. So that's the emulators for the first 5 computers that I owned. Let's take a look at the real hardware. I've set up my own mini museum here in my office. Take a look. Here they are. The Timex Sinclair 1000 with a 16K memory pack attached. There's the Commodore VIC-20 and its accessories and joystick and CPU. I've also included the CPUs for all of these. Here is the Atari 600 XL and its accessories and joystick. Here's the Commodore 64 with its accessories and joystick, and here is the Amiga 500 with its accessories. Here's the Zilog Z80 used in the Timex Sinclair 1000. This processor ran at 2.5 MHz. Sounds faster than the MOS Technology 6502 and variants of the other 3 8-bit machines. Even though it had a faster clock speed, instructions took more cycles, so it really didn't help. Next is the 6502. All 3 of these other 8-bit machines use different versions of this processor, so they all use the same set of opcodes if programmed in assembly language. They all ran at just a little over 1 MHz. The Atari computer used the 6502B, a slight variant of the 6502. Commodore 64 also used a variant, the 6510. Chips were also used in the NES and also the beloved Atari 2600. There were variants of both of these. The Atari used a 6507. Then there was the Amiga, the first 16-bit processor machine that I owned, and that used a Motorola 68000 running at about 7 MHz. I already have the Commodore 64 basic and assembly versions and the VIC-20 assembly version working. We'll be looking at them soon. Please like and subscribe and leave any comments or suggestions you may have that could make these a better experience. Next episode, I will be showing a port of Invader for Linux on Raspberry Pi and also PC using Python and the Pygame library. Until then, bye, and I'll talk to you next time.